So today then, we proceed with the next distribution, which is called exponential probability distribution. Exponential probability distribution. Exponential probability distribution. And you write this. Like this. This is a distribution used. This is a distribution used to study service time. Study service times in institutions, or usefulness of products, First of all, the computation ZAL, probability that T is greater than or equal to T is given as E u raised to power minus UT. Probability that we have T1 here less than or equal to T, which is less than or equal to T2, is given as E raised to power minus UT1 minus E raised to power minus UT2. And then probability that T is less than or equal to T is given as 1 minus E raised to power minus UT1. And remember, E is 2.7182 and U is equal to 1 out of mean service time. Mean service time. So that is what we call exponential distribution. It is used to study the distribution of service times in institutions such as hospitals, such as hotels, such as banks, and so on. As in, we would want to know, when you go to the hotel and you place an order, how long does it take for you to get it? When you go to the hospital and you are in the doctor's room, how long does it take for you to be served, and so on. It also concerns with the usefulness of products such as bulbs, a bulb like this one. When you buy, for how long will it serve you? So all those are called service times. Now, this topic used, or this method used to be very popular in a method we call queuing theory, but in the new syllabus, queuing theory is no longer part of the syllabus. I don't know even why they forgot to remove this one, because that is where it's more applicable. But now that they retained it, we will do 1 or 2 examples. So we go to our handout. There are some examples there for some illustrations. Sarah, read for us the first question about exponential.
The same taken by the share in the second bank customer is an exponential distribution. The mean of which determine the probability that the customer will be set for a period of at most 10 minutes, Roman 2 between 10 and 20 minutes, Roman 3 more than 8 minutes.
Thank you. So the first thing is to know U. They have said the average time is what? The average time to serve the customer is 15. So mu is 1 out of 15. That is a very important thing. The second important thing is to remember that E is 2.7182. So the first one, when you are told at most 10 minutes, is that what they're saying?
Yeah.
Now, at most means 10 or less. So that is the probability that T is less than or equal to 10. So going by this formula that we have here, going by this formula and substituting straight, it will be 1 minus E, that is 2.7182, which is raised to minus 1 out of 15 times 10. Times 10. So work out that and give me the answer.
Zero point four eight six
0.4866. 0.4866. The next one you're told it is what? Between 12 and 20. Between 12 and 20. 12 is 16, 20 here. Now we use our formula here, this one of between. So it is going to be 2.7182 raised power minus 1 out of 15 times 12. Then you minus 2.7182 raised power minus 1 out of 15 times 20. So give me the answer. But they can never be negative. Make sure you are opening the brackets. Nasema 2.7182 raised to open the brackets. Minus 1 out of 15 times 12 close the brackets equals. You're taking too long.
0.1847.
The final one. 0.1857. Those are online. Make sure you're also sending your figures. The next requirement is probability that we are more than what?
18.
So greater than or equal to 8. This one is very direct. It is 2.7182. You raise power minus 1 out of 15 times 8. 0.586. Good. So that is the way to handle an exponential distribution question. So because it is very direct, I don't intend to do any other. I have said the first thing when you read a question about exponential is to know the mean so that you get your mu. Then to remember this is 2.7182. And then to remember these formulas and you apply. You know which formula applies where, so you apply them. So on your own, you can do the questions that follow that. So that with that, we can proceed to the next distribution, which is called normal probability distribution. Normal probability distribution. Normal probability distribution. And we write that this is the most popular. This is the most popular distribution. It's the most popular distribution because it is applicable in almost every situation. Because it is applicable in almost every situation. Full stop. It requires that data should have. It requires that data should have a mean of 0. A mean of 0 and a standard deviation of 1. And a standard deviation of 1. First of all, if these values are not satisfied, the data is standardized using the following formula. The data is standardized using the following formula. Z is equals to X minus X bar divided by standard deviation. Z is equals to X minus X bar divided by standard deviation. Another point is that the value of Z, is used to obtain the probability of the interval. Is used to obtain the probability of the interval between X and X bar. Between X and X bar from the normal tables. From the normal tables. The distribution is asymmetrical, curve, as shown below. This y-axis So this is x-axis. This is x bar, which is 0 there. Standard deviation there, which is 1. This area here is 0.5, and this area here is also 0.5. So something is called symmetrical if it can be divided into 2 equal parts. Remember, we say the whole probability should add to 1. So if it should add to 1, when you divide 1 by 2, you get this side is 0.5 and this side is 0.5. From here up to the end, 0.5, from here, 0.5. I've already said this is the most popular distribution. We will be getting it almost everywhere. And it's also the easiest of the distributions that we have covered. I think 4 or 5. This is the easiest of all. So that now should be question what? That follows. That is under normal. Read for us the sentence or the statement.
Suppose a normally distributed random variance x practice and standard deviation of failure. When the following probability
ya kwanza ni
x equals to x.
Good, thank you. So when you are told x equals 23, is it equal or greater than?
Greater than.
When they tell you that probability that x is greater than 23, what you do, you draw like a small curve, not a big one. There's like a small one like this, not a very big one because you draw very many. Then hapa katikati unaweka x bar. Tumeambiwa that data as a mean of what? 30. And make sure you are writing as I'm writing. You see x bar, I'm writing that below it. Lakini kama unataka kuandika kando, like you want to put x bar iko hapa alafu 30 hapa, then you connect them like that. Otherwise, ukiacha hivyo without this, someone will think x bar iko hapa, 30 hapa. Then we are told standard deviation is equal to what? So standard deviation is 7. So when you are told, first of all, this one is a number, right? If you look at the normal, the one that we have drawn up to upper equals 0. So if you are going towards this direction, unaanza kupanda kwa positives. If you are going on this side, unaanza kuenda kwa negatives. So at this point now, hii ni 30. Ukaambiwa utafute 23, utaipata side gani? 23 iko wapi? Ukienda na huko ndio utapata 23. 23 iko na huko chini. So sasa hapa unasema x1 is 23 actually. And this kadab here that we make has nothing to do with the numerical difference between this and this. It has nothing to do with the numerical difference, just for illustration purposes. So when they want x greater than 23, tunataka sasa hii side ya juu ama ya chini? Ya juu. So you shade like this. You want this one. The area that you want is shaded that way. Then sasa hapo chini unasema Z1 is equal to x1 minus x bar. You divide by standard deviation. So this will be 23 minus 30. You divide this by 7. Give me the answer to 2 decimals. The values of Z are given to 2 decimals. Negative 1.00. From the tables, probability that x is greater than or equal to 23 equals I want you now to go to the back of your past papers. That's where we have tables. After ile table unaona imeandikwa normal curve. After table imeandikwa normal curve. Kama umeiona inakaa namna hii. On this side, kuna values zimekimbia from 0 to what? 9. This side kuna values zimeanza 0.0 zimekimbia all the way to Sasa hizi zenye ziko hapa, they are the first decimal, the value of z to 1 decimal. Na hii hapa juu is the second decimal. So what you do, sasa kama hii utaenda mahali kuna 1.0 alafu uende kwa column 0. Ulisomee what is there. 0.3413. 3413. And something else that you can notice, ukiangalia hiyo table hakuna mahali kuna negative. Sindio? Lakini unaona hii answer yetu iko negative. So you read both like they are the same. Kama ni negative, unasoma like it's positive. Positive, unaisoma tu ikiwa positive. But later on, and you see when we start doing some other questions, as you now work backwards, this side may be required to be remembered what it was. Okay. The other thing, I have told you and we have written, when you use this value of z to go to the tables, this probability that you get, it is for the interval between x and x bar. That is something you must never forget as long as you're in the normal tables. It is the probability kutoka hapa kwa huyu mpaka hapa. So the probability kutoka kwa 23 mpaka 30. So the whole of these other space, we don't have it, but we still require it. But unajua from here tumechora the general one, from here mpaka mwisho ni 0.5. So you simply add 0.5 and that gives you 0.8413. That is how you get the sio tuko sawa. Haya, tusonge kwa mwingine. Mwingine anasema nini? X is less than 20. So probability that X is less than 20. Probability that X is less than 20. So again, unachora ka table. Hapa table kanachorwa namna hii. Hapa unatuambia ni X bar tunajua ni 30. Standard deviation tunajua ni 7. Sasa 20 sitakuwa somewhere here. You call it X1, 20. Now, when you're told less than 20, which side do you want? The lower side. So you shade this one. You shade that. Then quickly you now get Z1 as X1 minus X bar. You divide by standard deviation. So this will be 20 minus 30. You will divide by 7. So you give me the answer to 2 decimals. Negative 1.42. Then sasa unatuambia from the tables. We normally say from the tables because there is another formula that can be used. So you must tell whoever is looking at your work where you got the answer. So from the tables, probability that X is less than or equal to 20, it is 0.5 minus. Sasa enda kwa table, unisomee hii 1.4 column 2. 0.42 242. 0.4. Okay. So you subtract and the answer is, yes, Brian, I can see your answer, good. When you subtract, you get 0.0. 778. Good. Sasa, angalia hapa. Tumesema when you go to the tables, hii inakusaidia kupata probability ya X1 to X bar, 20 to 30. So hii yenye tumesoma ni probability ya kutoka hapa mpaka hapa. But that is not what we want. Tunataka hii ya huko chini. But unajua kutoka hapa mpaka huko chini ni 0.5. So unang'oa yenye hutaki, unabakisha yenye unataka. Haya. The next the probability that X is between that 2 and 40. Probability that X is between that 2 and 40. That 2 and 40. So sasa hiyo nayo you draw a small curve. Chora hivyo. Nakuwa namna hii. So this is X bar, which is that X1 here will be that 2. X2 here will be 40. Na hii ndio region tunataka. The one between that 2 and 40. So standard deviation here is 7. Haya, sasa let's get Z1. Z1 is gotten as x bar, x1 minus x bar. You divide by standard deviation. So this will be that 2 minus 30. You divide by 7. Two 9. Okay, then we get Z2. X2 minus x bar. You divide by standard deviation. This will be 40 minus 30. You divide by 7. 1.43. Okay. Sasa angalia hapa. If you look at the first two questions that we have answered, our x zilikuwa on the lower side of the bar. And the two answers for Z, they were negative. That tells you, as long as your x is on the lower side of x bar, your Z will be negative. But ukikuja huku juu, when you're on the upper side, they will be what? Positive. That knowledge is very important. And you see that when you will be given a question to go backwards. So meanwhile, we proceed and say, from the tables, probability that x, or we are between that 2 and 40. Now look here. Tukienda kusoma kwa tables, tukisoma hii ya 0.29, it will show us the probability ya kutoka 30 mpaka that 2. Hii, it will show us the probability ya kutoka 30 mpaka 40. So for us to get our desire of that 2 to 40, we must then get the probability ya kutoka 30 mpaka 40, tung'oe 30 to that 2. So, nipatie hii kwanza. 1.43. 4236. Alafu sasa usomee hiyo ya 0.29. One, 141. $0.3095. And if someone was to ask you to get the percentages, you just multiply this by percent. Sasa kama hii itakuwa that 6.95%. You can put that because you may get another one in a convert to percent. These answer yenye tumekuwa tukipata, you just multiply by 100. Oh, it is 30. 30, so 30. Aya, huyo mwingine probability that we are between 27 and 35. Between 27 and 35. So takuja huku nitafutilie my x1, which is 27. So I shade this, and my x2 is 35. So Z1 will be 27 minus 30. you divide by 7. Four, 3. Huyu mwingine ni 35 minus 30. Divide by 7. 7, 1. So from the tables, the probability that we are between 27 and 35. Sasa, angalia. This one will give us the probability kutoka 27 mpaka 30. Huyu atatupea probability kutoka 30 mpaka 35. So in order for us to get our desire, we will have to add. So nisomee hii at 0.43. 664, good. Haya, tuende unisomee hiyo ya 0.71. 2612. Zero 0.4276. Good. Huyo mwingine? Greater than 34. X is greater than 34. So if X is greater than 34, we begin again by drawing our table where we have X bar. This is 30. This is X1, that is 34, greater than. Standard deviation is 7. So our Z1 will be X1 minus X bar divided by standard deviation. So this is 34 minus 30 divided by 7. 0.57. So from the tables, my probability that X is greater than or equal to 34 is 0.5 minus, so here at 0.57. 2157. Now we are subtracting because what we shall get here, 200, it is between 30 and 34. Two, 8, 4, 3. The next one is Nasema. Or measure. Good. So Sarah tusomee hiyo nyingine kufuata. Question 25 now.
One or 3.60 shillings and the standard deviation of 8.7 shillings. Determine the percentage of interest that A over 120.05.
Okay, good. Percentage that is over shillings, let's say about 110.05. So the percentage is the other word for probability, as I have said. So sasa again tunachora kameza as usual, whereby our mean here umesema ni 103.6 and standard deviation is 8.73. Standard deviation is 8.73. Sasa, when you are told over 120, kumaanisha your x1 for somewhere here, x1 is 120.05. So tunataka hawa wako juu. That way. So my Z1 will be x1 minus x bar. You divide by standard deviation. So this is 103.6 minus, no. Is 120.05 minus 103.6. You divide by 8.73. 1.88. So from the tables, probability that x is greater than or equal to 120.05. Obviously, it will be 0.5 minus. Yeah, because tunataka hiyo ya juu. So nisomee kwa table 1.88 inatupea nini? 699. $0.0301. So ukimultiply na 100, it is 3.01%. 3.01%. Hiyo ingine ya pili nasema below is below 72 is below 72.25. 72.75. So x bar tumesema ni 103.6. Standard deviation is 8.73. So 72 huku. X1 is 72.75. So below here. So sasa my Z1 will be x1 minus x bar divided by standard deviation. So this is 72.75 minus 103.6 divided by 8.73. Negative 3.53. So from the tables, from the tables, probability that X is less than 72.75. It is 0.5 minus, sasa uende kwa tables, usome hii. 998. So get the answer and multiply by 100. Aya, sasa sio tumemaliza. Aya, the next one wanasema nini? That is between shillings 80 and 17.6. X bar is 103.6. Standard deviation is 8.73. Now 83 here, we have X1 here, 83.65. X2 here is 117.6. So we are interested in this one. So that tells us that Z1 should be X1 minus X bar divided by standard deviation. So this is 83.65 minus 103.6 divided by 8.73. $2.29. Haya, tukimbie kwa Z2. It is X2 minus X bar. We divide by standard deviation. So this is 117.6 minus 103.6. We divide by 8.73. 1.60. So from the tables, probability that we are between 83.65 is our X and 117.6. Sasa tutaanza na hii ya 2.29. 2.29 itatupea twende sasa usome ya 1.60 452. So you now add 382. So hii ndio wanaita 93.82%. Huyo mwingine anasema nini?
Approximately 25%.
What percent is greater?
25% increases and for the
5% and of greater amount. What that means is, first of all, you do your normal table. Sasa ukishafanya hivyo, nakuja hapa unasema this is X bar 103.6. Standard deviation here is 8.73. When you are told greater iko side gani? This side. So tunataka hapa this greater one here zikue 25. So this one is 0.25. This X1 hapa ndio hatujui, is the X bar there. I mean the X that is unknown. But tunajua vizuri sana from other workings. When we were getting hii probability ya huku, tulikuwa tumesema 0.5 minus something. So ndio? Yeah. So that something that was subtracted must now be obtained here as 0.5 minus 0.25, which is 0.25. Sasa hii hapa ni hiyo space ni 0.25. Tumeelewa hiyo? So kama tushaelewa, now how do we get, for us to get this one, tulikuwa tumeenda kwa tibu na tulikuwa tumepata value ya Z. Hiyo value ya Z tulisoma huku kando ilituleta huku ndani. So tutarudi huku ndani sasa. Tutafute 0.25. Ukishaiona huko, unisomee the value that is in the row and the value that is in the column. And as you look for it, just a minute, you see these curves do not touch this line. That means there is a gap, an error. So you may not get 25 or 0.25 exactly. So what we do, you take a value that is slightly above or slightly below. And then as you look for that Z, you must know will it be positive or negative. And I've already said as long as your X1 is on the higher side, that value will be what? Positive. So sasa itabidi nikuja hapa niseme from ama kabla ya kusema from we know so well tulikuwa tunasema hivi Z1 is X1 minus X bar out of what? Standard deviation. Sio ndio formula tunatumia. So from the tables, Z1 will be positive. Aya, nisome now. Yo. .68. Okay, good. 0.68. So kama ni 0.68, then kupindua hii bali hapa. You can first of all now substitute. Hii tunajua sasa ni nini? Na idiot tunajui, X bar tunajua na standard deviation But ukipindua when you make X1 the subject, tapinduka hivi. Hiyo atakimbia hivi. Tubaki na standard deviation Z1 equals X1 minus X bar. Then X bar iruke. So X1 will then be X bar plus Z1 standard deviation. If you make X1 the subject of this, so our X bar, we already know it is 103.6 plus 0.68, which is multiplied by 8.73. $109.5 shillings. So anything that is greater than 109 will form 25% that are greater. Wewe mwingine tunaambiwa okay. 95% symmetrical about the mean. About the mean, that means inagawanyishwa at the mean value. And I have told you a while ago that something is called symmetrical if it is what? If it is what? If it is divisible into two equal parts. So this is the mean, X bar, which is 103.6. Standard deviation here is 8.73. 8.73. Sasa you divide into two equal parts hapa hivi na hapa, so that the whole of this hii region yote hii hiyo it is 0.95. And hiyo 0.95 ni kumaanisha something like this. Hii ka space hapa it is 0.475. Na haka kengine it is also 0.475. So that when you combine them zinakupea 95. Sasa huyu x1 ndio hatujui, na huyu x2 vile vile hatujui. Those ones are unknown. From the tables, Z1, now Z1, because tunaona X1 iko on the lower side, so Z1 should come in as a negative value. It will be negative. Sasa utafanya tu venye tumefanya kwa hiyo ingine, because we know hii ni probability yenye tulisoma that was between this and this. So tafuta 0.475, unisomee value in the row and the value in the column. It should be 1.96. 1.96. Hakikisha the typing hapo kwa columns iko sawa. Kuna venye kama zingine hazikuwa right vizuri. Those columns are supposed to start from 0 all the way to 9. Kama hiyo kupangwa kuna some karatasi hazijapangwa vizuri. So you can easily confuse. So it is 1.96. Thus x1 should be x bar plus z1 standard deviation. So this is going to be 103.6 plus minus 1.96 times 8.73. It's a factor hii negative. Hmm? 94.6. Z2 will be positive 1.96. Inafanana. It's only that sasa iko on the higher side. So x2 will be x bar plus z2 standard deviation. So this will be 103.6 plus 1.96 multiplied by 8.73. .7. 120.7. Huyo mwingine this one. Eight, 49. Okay. Iko sawa. The second. There is another. Okay. So I think now on your own, you shall do the other questions that remain there. There are 3 of them, Yeah. So there are 3 of them. So you do that, plus any other that you find in the past papers. Now, we had said that we are meeting this Sunday from 6:30. So 6:30 to 10:30. 6:30 to 10:30. So make arrangements to be there. Now we are through with that part of probabilities. So we are now headed to the next topic, decision making. So I will give you the notes that will guide us. Those who are online, I will send you the soft copies, but those who are physical, you have those notes. So that is what we shall discuss on Sunday, God willing.